Hey everyone, welcome to another Manufacturing Live. This week, we're fresh off 3D Experience World last week, and we have one of our cool partners with us. I would like to introduce Daniel from Tormach. Daniel, welcome to the show, and please tell us a little bit about yourself and what it is that Tormach does for the two people on the planet that don't know.
Oh, it's very flattering. I'm Daniel Rogge. I'm the CEO of Tormach. We are a manufacturer of capable, affordable, easy-to-use machine tools. So milling machines, lathes, router, plasma table, industrial robot. Employee-owned company based out of Wisconsin. And hopefully you guys are already familiar with our products. But if you're not, I understand you might find out a little bit more during this conversation.
Yeah, I mean, that's sort of our hope here, right? I'm a Tormach user myself. I've had a couple different machines over the years. I got a 24R router in the shop right now that we do testing on. But I think as we go through this, I want to talk a little bit about the evolution, where you guys got started, and then we're going to sneak our way up to that really killer machine that you got sitting behind you. So let's sort of start about, not just being a SolidWorks customer, building these machines and designing them, but like, how did you guys start and evolve, and where do you fit in the world?
Yeah. So company was founded a little over 20 years ago with the idea that we wanted to build basically a Bridgeport, but updated for the 21st century. So 20 years ago, if you remember back that long ago, getting a CNC machine into your garage was not a thing. CNC machines were, 480 volt three-phase power, often required a reinforced concrete floor, were super hard to use. Typically, you're going to a trade school for a couple of years to learn how to be a CNC machinist. They were really, really expensive. And the founder of Tormach noticed that people had started retrofitting manual machines just in an effort to try to get access to CNC. And he thought it would be a great idea to kind of provide that as a easy to purchase, completely pre-made product. And that was the impetus for the founding of the company. Basically, providing something that was sized like an old Bridgeport. So, 1.5 horsepower spindle, similar travels, but controlled by a computer, and easy to use, and accessible, meaning affordable, ran on single phase power.
Which is a big need, right? Because affordability and size have not always been together when it comes to CNC equipment. Before I ask the next question, I do want to remind everyone this is live, so make sure you guys ask questions, and we'll filter through them and try to get as many as we can throughout the next 50, 55 minutes, however much time it takes us. But one of the things that's interesting, you sort of mentioned there, my first CNC machine in my shop was an old Matsura 760V with a Yaznak, and still had the tape reader on the side, and it was hard to put in, and I had to have a phase converter. And although it was a big piece of iron, it was not the most efficient machine to have in a shop to go out and run at night and things like that. And some of the things that I think is unique about a Tormach is the controller that you guys have, the Path Pilot. Can you talk a little bit about that? Because to me, that seems to be like really the key to unlocking the power of all the equipment that you guys provide.
Yeah, sure. I love the story about your old Matsura with the tape reader. And people ask me, especially friends of mine that are not CNC folks, they occasionally will say, well, how long does one of your machines last? And the answer is, mechanically, CNC machines last a long time. I mean, they're very easy to maintain. Even if you have parts that wear out, they're pretty replaceable. These are not disposable devices. And I don't just mean Tormach's products. Any CNC machine, the cast iron does not rot, right? But the controls die out. And so, I bet your Matsura, if it is still in existence and hasn't been scrapped, is probably mechanically either a sound machine now, or could be restored back to a sound condition. It's the control that's really problematic. And that's one of the great things about Path Pilot. And I don't know, I can't really see the video feed here, but maybe you can see our controller. We use a Linux, real-time Linux PC operating system for our control. And what that allows us to do is continue to update the software regularly. So instead of buying a CNC machine and having the control frozen in time at the year that you purchase it, we allow people just to download updates every time we've got them available. And that actually extends to the entire operating system. Occasionally, we have to do an update that's just above and beyond the normal control software update. And the last time we did that, we sent people out USB sticks with an entire operating system on them, and allowed them to completely update the entire computer. So that's something that I feel is really important when it comes to CNC machines. Is machines last almost forever. Software, as you probably know, is like a 5-year proposition at best for most software. I'm talking to SolidWorks. You guys know what I'm talking about. I can't imagine that you would be able to run software that you wrote 10 years ago on modern equipment. That would just be ridiculous. So the ability to constantly upgrade the software is really important to us, and I think really important to our users. I don't know what else you'd like to know about PathPilot. Super user-friendly interface. Tried to keep it as simple as possible for new folks, but make it powerful to handle, like high-speed machining, constant tool engagement, adaptive tool paths. It's very, very high-performance software.
Yeah, I think the you mentioned like my old Matsura, it could still cut tents if you needed it to. However, the RS-232 and drip feeding it in and making sure there's enough memory and like all the other steps that you had to get it to there was not for probably a novice to get started doing those things. But one of the things like in the PathPilot that I thought was interesting is, I had a Series 3 1100 in here for a while, and then I had my 24-hour router. You guys have been partners with us at 3D Experience World for, 6 or 7 years now. And we've had your plasmas in there. We've had your MXs in there. This year we had the 1500 that's sitting behind you. And the thing that's always impressed me about what you guys do with the PathPilot control is it's the same whether I'm running the plasma, the router, the mill, or even the lathe. And to me, that's really the piece that unlocks it all.
Yeah, same with the robot, actually. We tried really, really hard to make the robot interface as familiar as possible to anybody that's used one of our milling machines. Yeah, I mean, when it comes down to controlling anything that interprets a machine code of some kind, whether it's G code on a milling machine or a lathe, or whether it's Python on our robot, you've got kind of the same set of tasks. And so we've got, user interface roughly broken up into a set of persistent controls that stays the same down at the bottom. And that's 1/3 that's basically program controls. And I actually have program in the middle of an optional stop here because I think we're going to show you guys some machining later on in this conversation. But we've got the program controls over on this third of the screen. We've got position and status readouts in the middle. And we've got kind of manual and jogging controls here over on the right. And then we have typically a tab of different, we call it a notebook with different tabs along the middle. And then, of course, the toolpath display. And this is basically the same regardless of lathe, mill, router. Clearly on the lathes, we kind of lock you into a 2D representation as opposed to this orthographic view. But otherwise, we try to keep things as similar as possible so somebody that has experience with one of our machines can easily transfer that experience to the other machines. That's, I think most people get that, but if you're in a school setting, if you're a teacher, that becomes super important because we've got like these little desktop trainer routers called XS Techs, and teachers are very easily able to get students familiar with the interface on our online simulator, and students can test out their code on the online simulator, and then they can move a couple of students over to one of the little XS Techs, and if you make mistakes, it's really not that bad at all. It's a pretty small machine, doesn't have a lot of power. And then the students can go on and graduate to one of our larger machines. And just makes everything more approachable, I think, when you have that familiarity between the interfaces.
Yeah, and I should mention we did have an XS Tech at 3D Experience World this year. It was over in the maker space. In years past, we had CNC 101 with them. I forgot about those being part of that, but they are really good in that. And, like back when I lived in Colorado, we helped Cherry Creek Innovation Campus go through and get a bunch of that stuff set up. And it was really cool to see how students just gravitated to it and it made sense. The other thing that I'll add, it was interesting, you mentioned the online simulator. One of the things that I always thought was cool, gosh, way back before it was popular, is your ability to have the Wi-Fi connectivity to it. So instead of carrying that prone to break USB drive out to the machine and stick it in, you can actually wirelessly connect and do those updates too, which I always thought was pretty cool.
Yeah, we've got transferring G-code files, especially if you bother to connect your computer either with a little Wi-Fi connection to Wi-Fi network or with the hardwire Ethernet, it gives you so much. There's the ability to, regularly back up your tool table or your work offsets. Transferring G-code files becomes super easy. You can map a network drive so that, posting code from your CAD/CAM package straight to the controller. You can even overwrite the file that's actively being machined. Like if we have a loaded file and the machine is doing something, and I notice I want to change the feed rate the next time I go through it, and I want to record that change in G-code as opposed to just using one of the overrides, I can actually repost that code while the thing is machining, and it'll hold off on that update. And as soon as it's done machining, it'll say, hey, we got a new version of this file on disk. Do you want to reload? That's just makes so many workflows. It's remarkable. It's only a few clicks to move some stuff over out of USB stick, but those clicks really count if you end up doing a lot of times during the day.
Yeah, and as programmers, we're never happy with what the program does, right? We always want to keep making those little adjustments through it.
For sure.
We got a little bit of feedback. I'll go through and read a couple here. The 3DEXPERIENCE 3D guy says, hoping to add a Tormach mill to my shop sometime soon. So at the end of this, we'll know where to go, which is tormach.com. We'll have that in here in a little bit. Eric says his 2016 PC NC 1100 has made a lot of parts. It's been a great machine. That's
great,
similar to the one that I had. And then Jason Poole, which I think everybody knows Jason from being an ambassador for Tormach, but also being here at Dassault Systems and SolidWorks, running the event last week in the shop floor. He says that he does a lot of WWE belts with it, and he runs a lot of things lights out on tight deadlines, and it's been great for what he does too. So far, nothing but a bunch of people that absolutely love the machines, which is great because, like I said, even myself, they're very cool, very easy to use, and have enormous amount of power and capability.
Great. So, I'm really glad to hear those comments. Thank you so much.
Yeah. In the software side, we always hear the mix, right? So when they're all positive, that's a great thing. That means we're going in the right direction and solving a bunch of people's needs.
Yeah. I don't know if you, if this is interesting to the audience who's watching the video. The other thing that I do want to mention about PathPilot is it's open source. And so we developed PathPilot back in 2013, 2014, and it was done in collaboration with an open source group called Linux CNC. There are two other open source groups that we participate in. The other two are Machine Kit and ROS, Robot Operating System. And those partnerships have been tremendous. So if you're an open source software advocate, then knowing that PathPilot is licensed GPL v2 is probably important to you. If you're not familiar with open source software and the benefits of open source software, essentially the idea is that there's a giant community of people, all of whom are developing improvements, enhancements, capabilities, contributing those back to the community. That includes Tormach. We push our enhancements back whenever the communities are interested in taking them. And we've gotten so much out of those partnerships, not just code that our customers are able to use and enjoy, but relationships with different hardware vendors. We've got a couple of employees that came to us directly from those communities. That's just been a fantastic partnership. Linux CNC, Machine Kit, ROS, all things you could research online if you were interested. Um, and and open source is something that we're really committed to, and it kind of dovetails in with our right to repair and kind of an approach to selling machine tools that's a little different from some of our industrial competitors up market.
Yeah, right to repair. That's a a hot topic these days in the Midwest, where you're from and where I'm from. So that's always always a good thing,
Right.
giving people.
John Deere was in the news as I was driving into work today. Yeah.
Yeah, yeah. I who knows where that'll go, but it's great to give people choices to be able to update and modify things as they go. It's also great to be able to have that community support to make the product better long term. I think that's a lot of things. Oftentimes, companies get into a tunnel vision of not getting enough feedback, and then ultimately they silo the product to something that is useful for a niche versus the wide open market.
Mm-hmm. Yeah, right to repair is an interesting one. Several years ago, we considered ourselves a real right to repair company because we didn't force people to hire a factory trained service technician to do maintenance or repair on their equipment. And we kept an inventory of all the different parts, circuit boards and drivers and other parts that people might need to keep their machines up and running. And to me, that was like, hey, right to repair. And we actually were called out on that by people that wanted access to, say, like the firmware that goes into one of the little microprocessors on our older control boards, or access to the schematic and bill of materials for some of our PCBs. And it occurred to me at that time, it's like, who on earth is going to be desoldering a PIC chip off of a circuit board, soldering a new one on and uploading firmware? Like, wouldn't they just want to buy a control board from us? We keep it in stock and we pay a reasonable, charge a reasonable price for them. But in fact, people in some instances are very much interested in doing that. And so we made a decision several years ago just to open all that stuff up. So up on GitHub, we've got schematics, firmware files, basically everything you'd need to put one of these machines together from scratch, with the exception of the solid models. So we've been, along with that kind of open source ethos, we've been moving more in that open direction. So far, it's been very positive.
Yeah, it's worked out great. And, like us with Shop Floor Programmer now being with 3DEXPERIENCE SolidWorks and having the kinematic components, we've been able to download the machines from you guys that you have on your website and create the kinematic models. So when we throw the vices and the fixtures and the parts on there, we can see how everything moves and runs. So when you post it out, it's exactly what you see in the software. So we've been able to take advantage of that open source stuff and be able to, work a little bit better and provide those. We do have one really cool question.
Sure.
And it comes from Eric. It says, being open source, what are some of the mods or hacks that some of your customers have done?
Oh, yeah. We see a fair number of hacks around accessories. So we've got some folks that are putting together, like a different probing system, different probing routines. We see hacks to providing different versions of, for instance, like the override knobs or jogging devices. This is an interesting one, and I get this question a bit, like, what about people putting PathPilot on non-Tormach machines? And we do see that pretty regularly, and it's flattering to me. It's kind of like if you were Ford and you heard about somebody taking a Ford V8 and dropping it into a Mazda Miata, you'd be like, oh, that's kind of cool. I mean, it's not my car, but I'm glad they're powering it with my engine, So we hear about folks that are doing that. It's not something we can support. It's not a business activity for us. We're not going to be selling PathPilot to people that want to retrofit other machines with it. But we do hear about people doing those type of mods, and of course, the open source nature of the software helps them out.
Yeah, on that 1100 I actually went and bought one of those jog pendants so I could run it like what I used to do in the shop.
There you go. Yeah.
Yeah. So, being able to just go order it, plug it in, it all works the way it's supposed to and everything functions. Like, I thought that was a pretty cool addition for the older machines, just, by habit, starting out in a shop, with the hand pendant and everything. Obviously, all the new machines have them, but I thought that was a pretty cool hack that someone was doing for myself.
Yeah. Nice.
So my guy, Eric Beatty, he says, I'm with the 3D Experience 3D guy. I want one big time. So Eric, again, you know where to go
Great.
get one, man. This is where you go.
Excellent.
So at the show last week, for us anyway, you guys have had these out for a little bit, but for us, it was a pretty cool debut of the machine behind you. Can you talk about that a little bit? And
Yeah.
then we'll jump into running it here in just a sec. But can you talk a little bit about that machine? Because that one is really amazingly cool.
There are some major differences with this machine that are worth pointing out. So the very first thing I want to mention is this is the first machine tool that we've ever done with an epoxy granite frame. So epoxy granite, also known as mineral casting, is the technology for building a machine tool frame where you use a silicon dioxide aggregate, a quartz aggregate, bound in epoxy, and it's cold molded into the shape of the frame. And then we use a very sophisticated and precise process called replication to create the very, very flat and orthogonal linear motion surfaces, so the surfaces we mount our linear rails to. That epoxy granite frame does a couple of things for us that we couldn't do with cast iron. One, the vibration damping on this machine is incredible. So cast iron, you know, people, if you think about a cast iron frying pan and you whack it with a spoon, it's going to ring like a bell, right? Cast iron, certain types of cast iron, and these are the ones that we typically use in the cast iron products we make, are better at damping vibrations that are inherent to the machining process than other types of cast iron. But epoxy granite is, you know, multiple times better, 7 times better at damping vibrations. And that makes a huge difference when you're cutting. First off, tool paths that will chatter on cast iron machines will not chatter on this machine. You don't need to be as good at fine tuning the machine to get good results out of this machine, because the vibration dampening is so good that, and I'm a real amateur machinist. I've worked for Tormach for 15 years, and I am still the kind of person that needs to go change my overrides after I post a program. On this machine, it really seems not to care where you set it. It just always sounds like it's cutting butter, which is a lovely, lovely thing. That results in longer tool life, better surface finishes, but the big one for me is just ease of use. The machine is a joy to use because you don't have to be as particular about tuning out areas of chatter. It's more thermally stable with respect to dimension. So as it's about 68 degrees here in this shop, but in the summer, sometimes we don't run the AC and it gets a little warmer. This thing grows or shrinks considerably less than a cast iron frame would. And so we've got better accuracy that results from that thermal stability. It's a very precise machine. We're able to get a higher level of precision with the frame and the linear rails on it than we could on our dovetail hand scraped turkite machines. It's faster. It's considerably faster. Part of that is using linear rails as opposed to hand scraped dovetail ways. But another big part of that is we've taken on a new motion control technology with this machine. So we're using EtherCAT servos, 750 watt servos on the axes, and that allows us to push this thing at 1,200 inches a minute with really high accelerations. The EtherCAT field bus that we use for those allows us to get a tremendous amount of information back to the control, which is really, really neat. It opens up some pretty interesting possibilities. Let's see, where was I? Sorry, I was getting distracted because it's something really cool that we figured out the other day related to that. Maybe I'll go into that in a little bit if your audience is technical and wants to geek out a little bit. Yeah, so in general, this machine has got this epoxy granite frame, better vibration dampening, much faster motion control, higher accuracy, better thermal stability, more spindle horsepower than any machine we've produced before. So it's really like the 1100 MX that our customers have been asking us for years and years. And it came with a bunch of ergonomic improvements as well. And so the entire machine, if you look in here, it's not like we haven't cleaned anything out in here. We were making chips right before this show, and the wash down bars and the coolant tank and the chip conveyor just kind of keep it clean without me having to get in there and scoop chips out. So,
well, I think it's interesting too. You mentioned the chip conveyor, which is new addition, right? You have wash down bars. You have through the spindle coolant, which is pretty cool. You guys have the
is huge. Yeah, I'm not sure how if you're a professional machinist and you've used a machine with through spindle coolant, you know exactly what that is capable of doing for you. But if you're not familiar with it, it is such an improvement to be able to get chips out of a hole. You can drill at speeds that are unimaginable without using through spindle coolant. So that's a huge productivity increaser as well.
And it's BT30, and then you guys also have a mist buster for it too, right?
Yep. Yeah, and 30 taper. I get questions about 40 taper, 50 taper, 30 taper. I think 20 years ago, if you were removing metal, it was clear how you're going to do it. You're going to put a lot of horsepower, a lot of torque into a spindle that was running relatively low RPM. You're going to use a big tool, and you're just going to plow that tool through a chunk of metal. And to do that, you needed a 50 taper tool holder, or a, depending on how much you're removing, 30 taper wasn't going to cut it. Those were the days where carbide tooling was rare and incredibly expensive. Now carbide tooling has come down in price. Also, CAD CAM systems have gotten incredibly more useful, and in particular, constant tool engagement tool paths allow you to get this kind of really deep, relatively shallow width of cut strategy. So it's a long area of the tool that you're engaging with a really small step over. And you've probably seen these on YouTube, meow, 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 meow. And what you get out of that is the ability to use smaller tools, use the entire flute length of the tool to remove material. And that means you can take a 1/4 inch or a 3/8 inch carbide end mill, which is much less costly than, say, a 1 inch carbide end mill. You can use it really efficiently at really high RPMs. High RPMs because you've got a smaller diameter tool, so your surface speed calculation works out to a high RPM. And so now I think you'll find that, sure, this machine will not keep up with a 30 horsepower, massive old thing that is taking a strategy, but you can use fast machines with smaller tooling in a way that gives you really high material removal rates. And that was not a strategy that was available to people 20 years ago, because the G-code programs, the programs used to create G-code were not there, didn't allow you to do it. Now we've got these constant tool engagement strategies that allow us to get the absolute maximum horsepower out of the machine for 90% of the tool path. And that leads you to this different paradigm, which essentially is high RPM, high axis feed rate, smaller, less expensive tooling. And that's where BT30, in my mind, really is the sweet spot. So 40 taper, 50 taper, not something we're going to be doing anytime soon with our equipment.
Well, and I think that, there's all different kinds of shops that do different things, right? And again, it's the right tool for the right job at the right time. And I also, I want to add to that, because 20 years ago, the computing power of a computer itself couldn't handle outcomes, right? But
your Matsura was not doing this. Yeah.
No. That was when we just threw more people at the problem. We didn't worry about how long it took. The difference today is we have less people, so we got to be more efficient. But, to your point on like our Delmia components or SolidWorks CAM Professional, we both have high-speed machining algorithms that we use for different things. We took John's 770 and took his load meter and did all kinds of tests on it with even the TTS tooling system. And it's interesting how, regardless of how we changed the settings, the way that the tool paths were created a constant load every single time, no matter how hard we pushed it, even to the point of stalling it just to see what it could do. So to your point of the software and the way that the tool paths calculate and all of those things really help open up how people can do machining today. It's a lot different
Yeah,
than when I started, let's say a couple
yeah,
days
for
ago.
sure.
So the one thing that I know everyone's waiting to see is how well does this machine run? So could we fire this up and run a little bit and
Sure.
take
Yeah, 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 yeah. Yeah, we can be happy to do that. If we get the camera on in here. So this is exactly what I was talking about earlier. We've got the carbide tool running in much faster than you would have had going before. So these are, 400 inch a minute feed rates that you're seeing, and 7,000 RPM spindle, and constant tool engagement. This is mild steel stock that we're using here, and we're just chewing it out. Eventually going to create the Tormach T. It's just a demo that we run here for the folks that come into the shop that want to see stuff.
That is pretty
Oh,
impressive. Pretty
yeah.
darn impressive. It's nice and consistent. Like you didn't hear like one side of the quadrant sounding different than the other. Like it was consistent all the way around how it was running. That's impressive.
Yeah, yeah, it really is. It's quite cool, and I don't know if we can kind of show you the finish here, but it ends up, and this is just a roughing tool pass, right? Like this is the middle section of a demo that we do that's a little bit longer, but it's just the hallmarks of that constant tool engagement tool paths. You see these kind of rather interesting motions here as it comes in to grab the T, and you can see the kind of chip load we're taking just from what's left there on the material. The top surface was done with a die-jet insert cutter facing path that we ran before making that T. But it is pretty amazing what you can do these days with the new cam strategies that are available.
Yeah. We do have a really good question. Does the 1500 MX have the same work envelope as the 1100 MX?
No, it's a little larger than the 1100 MX, and I don't want to get this wrong, so I'm going to ask Davey, who's standing behind me. What are the travels on this 1500? 19 at 19.7 in X, 13.8 in Y, and 14 in Z. So slightly bigger than the 1100.
Okay. And one of the things there's a couple things I want to hit up on that we saw at the show. The probe actually in the 1500 stays in the carousel, right?
Yeah. So wireless probe and tool setting option for the 1500, which really unlocks a lot of stuff. One is it unlocks the ability to do robotic tending of the machine. You can do robotic tending of a machine that does not have a wireless probe, but having the ability to probe the workpiece, make sure that it was placed correctly, make sure that it didn't get set down on top of a chip, process reliability checks that you get with a wireless probe, I would say are kind of a must for automating a work cell. The other thing it allows you to do is do some in-process inspection. And I'm sure your guys' CAM solution could make this pretty easy, but you can, rough machine the OD or the ID, whatever feature you really care about hitting the tolerance on. You could probe that, and then you could use cutter radiance compensation to alter the finish pass to really just nail the tolerance that you're going for. And then just in general, having the probe there and ready all the time without having to plug it in and put it in the spindle, you just end up using it all the time for all sorts of different setup activities that in the past maybe you'd be lazy and you'd get out the old edge finder instead of using the probe. So it's it makes a big difference from a usability standpoint. It's actually interesting how much more usable the machine is with that wireless probe and tool setter. But I think the major ones are it unlocks these kind of in-process checks for either tending or geometry and adjusting cutter radius compensation during a machine tool during a G-code program.
And that, I think that was one of the big things. First off, if you didn't come to 3D Experience World last year, you need to come next year, because shame on you. What they had set up and what they were running was amazing. And I think that was one of the testaments you sort of touched on there a little bit ago, is you had your robot, which we'll talk about a little bit more in depth here in a second, setting to the side of it doing machine tending. And the way that it all worked was in concert, like any production facility you'd ever see, where we have a vision system on the robot. It's picking up the raw stock, putting it in. Once it's all set in the pneumatic clamps, then from there, we're grabbing the probe out of the tool changer, probing everything, adjusting zero, then the robot would take the parts away and then stack them up. And through the vision system, it was finding where they were placed in a zone. It wasn't like you had this big elaborate fixture set up where all the parts have to be stacked perfect in a corner. So let's talk a little bit about the robot, because I think
Sure.
you may know Tormach, may not know the robot. And to me, when you couple that with the 1500 MX, I don't know why anybody wouldn't start there for automation.
Yeah, so we do have an industrial robot, 6 kilogram industrial robot that is called the ZA6. It is based on that open source platform that I was talking to you about earlier, called ROS, Robot Operating System. And in fact, a lot of our customers for the robot are people that are doing robotics research with ROS. We intended the robot to be used as a machine tending companion for the 1500. And so we were working on the two in concert. The vision system is an interesting one. We had, the first time we started doing machine tending with the robot in one of our prototype 1500 machines, of course, we set out the grid and we wrote some robot code to go pick from a grid. And that works in a totally normal way to tend a machine tool. But it does seem kind of silly that in this day and age, you need to rely on that. And so we instead grabbed just a regular old USB camera and did some computer vision recognition of workpieces. And we brought that to automate last year, I think. And it works. It's fine. There were definitely issues where if the lighting changes dramatically, that approach, just using an RGB camera, is pretty sensitive to changes in lighting. And so the next draft of that was to use a LiDAR sensor. LiDAR is a laser range finding device that you find in self-driving cars, you find in your little robot vacuum. So if you have a Roomba, that's actually the module that we used at the demo that you saw just last week in Houston. And so we use that LiDAR sensor to localize the workpieces, and then the robot can go pick them up on the table. And that means you don't have to create this grid for all the parts that you're going to store. And of course, if you're just doing the same part over and over again, you're making 100,000 of them, a grid is a totally reasonable solution. But if you're doing kind of a high mix, low volume thing, you need a different grid for different shaped parts. That can be a pain in the butt. The other thing is the grid introduces some complexity from the user interface standpoint. It's not just, okay, XY grid, here's the spacing in X, here's the spacing in Y. You also need to know what's the start position of the grid. Do I want to start from the very first grid position, or did something happen 15 work pieces in and I need to resume the program from the 16th grid position? Now you need a user interface to support that. So it just seemed really clear to us that using computer vision to solve that problem would be a lot cooler. The other thing the grid allows, the computer vision allows us to do that the grid was challenging with, is that we could easily stack work pieces and have the robot grab off the stack. And it doesn't have to be like a super organized, neat stack. It's really just, you saw the demo in Houston. Just toss the things on the table in any old stack and it'll go find them and put them into the machine tool. The other cool thing, I think, about our robot and our machine tool working together is that most robots communicate with the machine tool that they're tending just using like a dry contacts implementation. They've got maybe two inputs and two outputs connected to the machine tool, and it's just a handshake. Hey, are you ready for me to put this into the vise? Oh, you are? Okay, great. I'm going to go put this into the vise. And the mill then might say, hey, are you done with your operation? Am I okay to start the G-code program? And you write both programs in a loop, and that works. That's how 98% of machine tending is done right now. What we did, because we write the control software for both the milling machine and for the robot, is that we had a really tight connection. So the robot can, for example, send individual MDI commands to the mill. And so what you saw in that demo, and I don't know if you have any B-roll of it that you want to show, but what you saw in that demo is the robot reaching in, picking or placing something from one of the vices, and then the vice moving out of the way, the robot flipping the part over, the vice moving back under the robot setting it down. So kind of like a coordinated dance between the mill and the robot. And that makes stuff a lot easier when you're trying to move a robot arm around with a large workpiece and two grippers on it inside an enclosure of a milling machine. Just being able to move the mill out of the way and have the mill involved with the tending made a huge, huge difference in our ability to move what are relatively large workpieces. I think we did either 5 or 6 inch soft jaw. I don't remember which demo we brought to Houston, but it was one where when you've got, one in each of two grippers on the end of the robot, it takes up a lot of physical space, and you're trying to flip stuff upside down inside a tight enclosure. Being able to move the mill around really, really helps.
Yeah, it was really cool how everything worked in concert, and I'm glad you brought that up because that did make that presentation, how it flowed, very unique from what you traditionally see. And
Right.
I think that the one thing that there's a couple things that I didn't mention, and then I want to throw in a comment from one of the people watching is, on top of all of that communication, one of the things that we had set up on our side is we were pulling real-time process monitoring from your machines too. So every time there was a cycle, it sent to our ERP and MES system in DelmiaWorks.
Oh, cool.
And we had your machine connected, just like we had the FANUC and just like we had some other cobots that were there. Like everything was connected as a smart factory. Mm-hmm. So all of the open communication that's provided by Tormach makes it easy to put into a system that already exists for collecting data, which was, to me, pretty cool. When you start looking at growing from the shop to having 3 or 4 machines to all of a sudden now I need to know how much uptime I have in a week, you don't lose any of that ability no matter where you start. Mm-hmm. Mike has a comment here, and I'm going to try to read it. It says, as an EDM operator back in the day, we never had to deal with tool load like those CNC machines operators had to. They did very hardworking programming, making things work. Great job, Tormach.
Thank you, Mike.
And then there was another one that says, wow, that's awesome. This is something that I always wanted. So you guys are addressing lots of needs for people. And to your comment of geeking out, this is the SolidWorks community. So everybody geeks out over everything. So I appreciate all the explanation you're doing.
It is a ton of fun. If you guys, I will little brief segue into geeking out about what kind of information we get back over the EtherCAT bus. We were working on a prototype machine. Can't tell you much about the project because we try to keep that stuff secret until we're all ready to go. The machine that we had prototyped had a spindle that was out of balance. We hadn't taken the time to balance the spindle. And we noticed a sinusoidal following error in the x-axis servo during machining things. And we isolated that following error to having to being locked in with the spindle frequency. And so my first instinct was, oh, it's an axis motor tune issue, and we're actually seeing the tooth impact vibration in the following error. But when we did the math, we realized it wasn't 3 times per revolution, it was once per revolution, and it was the spindle balance showing up as sub-micron changes in the following error. Keep in mind, these things have 23-bit encoders, so you can see just the tiniest displacement from the commanded position is visible. And we were actually able to see an out-of-balance spindle in the following error on one of the servo motors with our software oscilloscope that was on the machine. And get this, when we went to balance the spindle, we had 3 different approaches. Two are rather traditional balancing methods. We're using an accelerometer. The third one was to actually use the following arrow from the x-axis servo, and we've got just as good of a result balancing the servo using that. So that's the geeking out part about the kind of information we get back from these motors and drives, and it helps us in the manufacturing. Helps us when we're building the machines to make sure everything is, completely made in a very linear way. We can tell by the torque curve on the motor as it goes from extensive travel, whether the ball screw and the linear rails are all perfectly aligned in the same plane just by taking a look at the torque, stuff like that. So anyway, that was the geeking out I was talking about earlier. Hopefully somebody found that interesting in the audience. It's a little technical for most, but
no, I mean, that's part of the cool thing, right? And like the pieces that we like to explore is oftentimes, it's like, ooh, shiny machine, but when you get in the nuts and bolts of it, the amount of data that you can collect from these components today are insane from, what it was 10 years ago compared to now. So, I'm sure all the people watching, they're all like, oh, wow, that's really cool. And they're going to be going and searching all those different ways now. But, that's one of the really cool components that I appreciate that you shared, because a lot of people just see machine tools as machine tools, right? And oftentimes when we go look at movies and they're talking machining and manufacturing, they don't always show us in the best light from a high-tech standpoint. So thanks for sharing that. We do have a question. Can the ZA6 be used with the 15L lathe?
Oh, it can. There's some caveats. So first, there's a general caveat. 20 years ago, what we wanted to do was make CNC machines more accessible, and that means making them easier to use, less expensive, and fit into spaces that were atypical, right? 5 years ago, we wanted to do that to industrial robotics, and we've been somewhat successful at that. But industrial robotics are inherently harder to learn than CNC machines. You would be shocked to find out just how much more challenging 6 axes is than 3 or even 4. And so we're still working on making things easier from that perspective. And really our focus has been on the machine tool side, not on the lathe side. There's a pretty easy way to automate a lathe, and that is that if you have, if your workpiece is, fits into a 5C collet, is of the diameter that fits through a 5C collet. So don't hold me to this, 1 1/4 inch or lower. A pneumatic collet closer with a bar puller is going to be by far your best way to automate one of our 15L lathes. If you can't do that because it doesn't fit through the bar puller, then if you can't do that because your workpiece is larger than 1 1/4 inch and won't fit through a 5C collet, you can't use a pneumatic closer, then you'd need a hydraulic chuck. And we don't sell a hydraulic chuck for this lathe. You can certainly buy one. You could fit one on. You'd need a hydraulic pump and a hydraulic reservoir and a whole lot of other stuff. So the answer is we do have people that have done this, but it's not something that we really have a solution for, and we have not made it easy. And our focus right now is on making it easy to do this with a mill. So hope that answered the 15L automation question.
Yep. Yeah, I think that does. And, it's one of those things, like it's progression, right? As you develop and as you look at market and you look at demand, and you look where it goes, right? Depending upon how it fits. You want to be really good at what you do as you go out, not just be good at a whole bunch of average things and then lose focus on what's important. So, to me, your answer was perfect and it makes total sense. So we're getting close to the end of our hour. I do want to address a couple things because everybody says they want to buy one. Where do they go to buy one?
Sure. Tormach.com. Everything that we sell is available online. If you want to talk to a human being while you do your research, you can schedule a pre-sales consultation. We've got people that'd be happy to talk to you about our products. We don't do any commission sales, so if you end up talking to Davey or Max or Rob or Dominic, they're going to give you information that's in your best interest, not information that's going to result in a commission for them, because we don't do that. Kind of different approach to selling machine tools than many. But yeah, www.tormach.com is where you'd start.
And we've talked about the lathe, we've talked about the mills, we've talked about the robot, but you guys also have routers, plasmas, and bandsaws, right?
We do, yeah. Yeah, we
So
have a great little bandsaw product called the AF50 Plus. It is a 7x12 bandsaw that has pneumatic automation. It'll cut remarkably long pieces. 50-inch is the longest chunk it'll do. It's a fantastic machine. It essentially is similar to like a $30,000 industrial automatic bandsaw, slightly reduced capacity, but it's available for under $6,000 with accessories and everything. So it's a great product.
okay, we have one question that came in, and they're asking about the surface grinders that you guys used to produce. They're wanting to
Yeah.
know where that magic object went.
Well, that magic object became too expensive for us to produce and sell at a price that we thought was reasonable for our customers. So that magic object went into hibernation. Um, we're an employee-owned company. Our employees have really strong feelings about wanting to provide value to our customers. I know that sounds cheesy, but it is true. We have had a number of products over the years that our employees killed, not because they weren't profitable for us, but that because our employees thought, I don't want to sell this to somebody. So we had an injection molding attachment that I thought was super useful for schools that allowed people to do small injection molded parts. That one didn't make that cut. We had a product called the Duality Lathe that was a small manually controlled mini lathe that you could put on the bed of one of our milling machines, and you could use the mill as the X and Z axes for that lathe. That was another product that our employees felt like was not a great value for our customers. The surface grinder was one where we liked the product quite a bit, but the manufacturing costs kept going up, and it got to a place where we thought our customers would be better off spending more money on industrial solution than on that particular surface grinder. So that one's unfortunately no longer with us.
And I mean, that makes perfect sense, right? That's part of the evolution. The 1100 I had a duality lathe attachment with it. So that one I have seen and messed with a little bit, along with the old school rotary with the indexable fifth. So
and we came up with a better version of the duality lathe. It's no longer a duality. You can't use it manually, but we call it the rapid turn. It's a 5C 5C turning attachment that you can put onto our mills. And it is a much better product and a much better value. So
yeah, and those look pretty amazing, and they're easy to set up and simple to get started, and all of those things.
Have an indexing plate. You can do some light machining onto stuff that you can make some really neat stuff with that.
Yeah. So it looks like the questions have slowed down. We're at the top of where we are. When we start talking about the future of Tormach, what are you guys working on next that you can talk about? Where do you see Tormach in the next 3, 5, 10 years from now?
And we're going to continue to try to make tools that are affordable and capable and easy to use. That is our sweet spot. I can tell you what we're not working on is larger 3-phase. We're not looking to replace a VF2 anytime soon. That's not our sweet spot. We're going to take the products that we make now and make them better, faster, more accurate, hopefully less expensive. I think a lot of people, over time, you think stuff should get more expensive, right? Because costs go up. I take a different approach. I actually think that things should get less expensive. If you want to go buy a 60-inch television, you can do that for about 1/10 the cost of a 60-inch television 15 years ago. I feel like Tormach's mission is going to be to continue to provide affordable machine tools. And as we go into the future, we want them not just to be affordable, but to increase the performance like we have on the 1500. And and this is I guess the big and is we're really committed to automation. I think that what we really would like to do with automation is have and I've said this before. I've got a 2-car garage. I live in Madison, Wisconsin. I would love to get to a place where you walk into a 2-car garage in a suburb somewhere, and instead of seeing a minivan and a couple of bicycles, you see Tormach mill, Tormach lathe, robot working together in kind of an automated, even lights out situation. We're not there yet. There are a lot of complexities to making that dream come true, but we're going to continue to work towards that, because I think that could help us bring cottage industry back to the U.S., and that's something that we feel pretty passionate about.
Which is pretty amazing, because we need more people building. Unfortunately,
we do. Yeah.
So, Daniel, I can't thank you enough for your time. I can't thank you enough for helping us with 3D Experience World and the shop floor. And ultimately, I can't thank you enough for being a SolidWorks customer for all these years. So if anybody listening wants to go learn more about Tormach, please go to tormach.com. I can tell you for myself personally, John Milbury, our Fab Lab, Tormach machines are great. We do all kinds of testing with them. They're amazing machines. And
well, thank you very much. And they're all designed on SolidWorks. So
yes,
thank
exactly.
you guys for making this all possible. We love using your products as well. So the appreciation is mutual, and I'm really looking forward to doing another 3D Experience World with you again next year.
We've already started planning, so we'll make sure that you guys are part of the process for the shop floor, and we'll see everybody in Houston. There is one thing I got to do to pay the bills before we close this out, Daniel, and that is we are actually changing our manufacturing live over to Make It Better. So starting in April, the series is going to change to what we call Make It Better, where we're going to explore a little bit more of the design and manufacturing component. Obviously, I'm a manufacturing nerd, but way back in the day, I started out in manufacturing engineering, doing design and all of those components. So stick with us on that. If you liked Manufacturing Live, stay tuned for Make It Better. So thank you enough, Dan. Thank you for everything, Daniel. I can't say enough great things about the partnership that we've had over the last 6+ years. And hopefully you guys stay warm, because I know there's a big snowstorm moving in here in Nebraska today. So.
Yeah, well, thank you very much, Mike. The feeling's mutual. Really appreciate the opportunity.
Thanks, everybody.
All right.